still pretty dark outside. So anyway, I've brought the radio inside. It's just a bit warmer to work in here. I'm going to take the board out and then we'll set it up standalone, and we will work on this board, and it will not go back into the radio until, by flicking this switch, I can actually read 15.360 or 15.810 coming out the other end of the board, because there's no point in me fitting it in the radio because it just doesn't seem to be working. But if I'm working outside of the radio, it's easy to work on it, easy to flip the board over, do repairs, make modifications and see why this thing's not working. So let me desolder the board and get it out, then we'll get it set up and we'll see exactly what's going on. Right, well, I've even changed the crystal. I'm still not getting anything out of it. The problem within the circuit though, that I'm finding, or I believe is the problem, is here I seem to be getting, I think I'm getting a short. So what I'm going to do is I'm going to take this capacitor out, and I'm just going to have the emitter of the transistor running straight to earth. I assume this is only like a decoupling capacitor, but I don't know. So I'm going to take that out, then that should allow me to see if I can get my 13 volts up onto the base of it here, and then I'm going to see whether it actually allows the crystal to oscillate and get signal out. If it does, then there's something wrong here, but that's the only thing I can see at the moment. So let me desolder one leg of this capacitor and lift it up so this join isn't here anymore, and then we just run straight to earth. Well, I may have just made another discovery. So let's put that there. If I run up this far side, you can see, well, the back of there, I've got 13.68. Then I get to the front of this resistor, 13.68. Back of this resistor, 13.68. Flick the switch the other way. Front of this resistor, inductor, 13.68. 13.64. 13.64. 0.76. I wonder if we've got a dodgy resistor. So let me take this resistor out. We'll measure it and we'll change it, and we'll see what we've got going on with that resistor. Right, you can't see the meter from there. Let's just lay it down there. Right, so it's awkward filming and doing measurements at the same time. Right, what do we got? Hopefully you can see that. Should be 3.3k. And it is. So it's not the resistor. It's this earth lead is causing a short, I am convinced. The only thing can be, maybe it's the transistor then. Let's do some further measurements. Right, I'll put this resistor back and we'll see how we go. So as you know, I built the initial circuit, which was a transistor switching crystal circuit. Went up through here and then went off to the oscillator. Well, that didn't work. I couldn't get any frequency coming out of this top point here. So I then went and built a revised circuit, and I swapped out the transistors for a couple of diodes. It's a fairly similar design, but again, nothing coming out the oscillator. Now what I've been doing is I've been running, I hope you can see this okay, I've been running out the end of the crystals, then coming along and going to pin 4 of IC202. But after doing a bit more research and going over this hundreds of times, working out why I haven't got any crystal frequencies coming out of this point here, I noticed this is going to the oscillator. I actually missed out a stage. And if I open this diagram up here, what we need to put in is an actual oscillator. So the next stage we're going to do is I am going to create this circuit here. which runs into one of the transistors I already have, 9-volt feed coming into here, and this is where the megahertz input will actually come out and then go off into IC 202.4. So this is what we need to build. Now, it's only a very small little circuit, because what I've done, I've had to order some more parts, but I've mapped it out already, just tried to recreate it on a bit of my perf board, and that's it there. It fills up 4 little squares 2x2 with my transistor and the bits in. So this isn't, none of these are soldered in at the moment, and they're just not, a lot of them are not the right values. They're just put there. You can see they're wobbling about, but I just wanted to see how big the circuit needs to be. So I will need to fit in the radio, that size board with this little oscillator circuit, and then in theory the thing should work. Now, I could have hidden all this, but I want you to see the problems that I'm facing as I do these things, because as I always say, I'm not an expert by any means. I'm learning as I go, and this was quite an important discovery. So to do this channel mod, you will need an oscillator board. Now, because I didn't realise that I needed this, I could have built this all on one board and fitted it in the radio, but I didn't, so I'm going to end up with 2 boards now. But it's a learning curve. Once I've done one, and if this works, this is my prototype, next time I do this to a radio, then I should put all of this on one printed circuit board and fit it in the radio, and it should work. So that's where we're up to. So I hope you are enjoying this so far. So I'm waiting for the parts to come at the moment, but I've just done a quick explanation because I wanted you to see what we need to do and how things are evolving. So we'll wait for the parts and I'll be back for the next stage. Good news, the postman's just come and our missing components have arrived. These are a 220 ohm, a 1K, 100 picofarad and 270 picofarads, so resistors and capacitors. Just made myself a couple of little circuit boards, so I've got another one for the future here. So we will take this one and we'll start fitting the components to make the oscillator circuit, which, if you recall, is this circuit here. So the signal comes in, we've got 2 10k resistors either side, 270 picofarad going from the base to the emitter on the 2N2222A. Collector goes up onto plus 9 volts coming in from the radio through a 220 ohm 0.01 microfarad. I don't know why Lexa's just gone off. Then we've got 100 picofarad earth, the 1K, 22 picofarad, and then the output here. So input 9 volts, input from oscillator here, output in theory 15.360 or 15.810 megahertz. Let's hope this works this time. So I'm going to lay the board out and put this circuit on, solder it on, and then we'll attach some wires on and see if this thing actually works. Board's finished now. So we've got this wire would be coming in from the previous board that I built. This wire here is an earth wire for this capacitor and this entire row of pins down the side here. This wire here is for the positive 9 volt feed, the plus coming in, and then you probably can't see it, but I've put a little circle there because that's where the red wire, which I've got soldered to IC4, needs to connect to this board. So we've got the input coming in from the crystal board, 9 volts coming in from here, an earth wire, and the crystal frequency going out. That's the plan. I've slightly changed the way I did the bottom of this board. Unfortunately, I lifted a pad, so I've had to use like link wires, but it's looking all right. So I'm going to run over this one more time, just check the thing looks good. I'll put you a clear picture up on because the GoPro's never good for zooming in. And then we'll get this and the other board in the radio, connect it all up and see if it's actually oscillating. Well, I need a 9 volt supply for the oscillator board, and I've been currently searching around the radio looking for one. And I think I found one on the back of the board here. There's a big capacitor and then there looks like a couple of resistors. And where did I find it? It's 12. There it is. Yeah, the top resistor on the right hand leg to the right of this capacitor at the back of the board here has got 8.9 volts, and when I key up 8.91, and I've still got 4 watts going out, so that's as good as 9 volts. So I'm going to mount a wire onto there, and that will power the oscillator board. So there's the wire fitted there for the 9 volt feed. I'll put a picture up on the screen now, we'll zoom in a bit as well so you can see exactly where it is if you're doing one of these and you're following. Right, so the board's all hooked up. Here's my probe. Right, let's see if we can get anything anywhere. Jesus, I can't even get in there. Oh, no, come on. Oh, you are kidding me. We have got 15.368, and if I flick to the other band, 15.816. Now we want 15.810 and 15.360, so we're 0.08 hertz off. Now I haven't done the trimming yet, so I need to somehow get a spare hand and get on the trimming tool, and we need to adjust that, and then we're going to be bang on frequency. Oh my god, my Colpitts oscillator is actually working. Get in!